Welcome to this video covering some of the main features of Alcatel-Lucent Enterprise's network management system, OmniVista. We're going to cover a few topics, including the main differences between the two versions of OmniVista, the on-site version called OmniVista Enterprise and the cloud-based version called OmniVista Cirrus, along with applications used to deploy, configure, and manage your wired and wireless network. So let's first take a look at some of the main differences between the two versions of OmniVista. Firstly, adding devices. In OmniVista Enterprise, switches can be discovered on the network via discovery profiles that are made up of SNMP and IP information. For access points, you need to add the AP MAC address to the system and boot the AP into enterprise mode. At this point, the network administrator will tag the AP as trusted and can then proceed to add the AP to the network. In OmniVista Cirrus, the process is a little different. In Cirrus, you first add the serial number of the device you want to add along with its device type. APs are booted into cloud managed mode, and both APs and switches will need internet access. Once the device has contacted Cirrus, the device then goes through the onboarding process to enable it to be managed by OmniVista Cirrus. For other differences, we can take a look at some of the menus. Clicking on Configuration for both Cirrus and OmniVista Enterprise, we can see that Enterprise has VXLANs, IP multicast, SIP, and Quarantine Manager. These are only available on OmniVista Enterprise, along with VM Manager or Virtual Machine Manager. Now, Cirrus is a subset of OmniVista Enterprise, and the applications that are not found in Cirrus are due to the fact that Cirrus is cloud-based and not located on the customer network, and the mentioned applications require that OV be located on the customer network in order for them to work correctly. With OV, we can carry out those tasks required to configure your network. So, for example, let's first create an IP interface. Here we simply give the interface a name. Let's call it My Interface. An IP address. From here, we have the option of binding the interface to a VLAN or something. We also have, if we had configured VRFs, we can choose which one we want. And at the bottom here, we have the switch picker so that we can select the device on which we want to add the interface. The interface has been added. We can click on the right here to see some more details. We can now see what interfaces are already configured on the device. We select the device that we want to investigate, and we are presented with a list of IP interfaces already configured on the device. Another example of a common core network task is VLAN creation, a simple task to perform via the OV GUI. We can create a VLAN based on a map, which means a topology map. In our topology view, you can create maps that contain those devices that you wish to be associated with the map. We will look at the topology view in a minute. The other way is to select the devices by using this menu here. As you can see, we have various fields to fill in if needed to create our new VLAN. As a side note, for a given page, you will find a question mark located at the top right-hand corner of the page, which will open a new window with a brief online help page for the page you are on, which gives some information about the fields in question. So here we can select a VLAN template, copying a previously configured VLAN's information. We add the VLAN ID that we want to use and a description at the bottom if we wish. And at the bottom of the page, here we select the device to which we want to add the VLAN. Select this switch here. And now at the bottom of the page, we select Next. So here we can see the VLAN and the switch that we want to use. And here we select which ports are going to be the default ports for that VLAN. So we'll select this port here, click on Next on this page. If we wish, we can add ports that would be queue tagged for the VLAN in question. Clicking Next, we come to the review page. And if we're happy with the information, at the bottom we click Create. The VLAN has now been assigned to the device. We can click on these links just to see some more information. And we can see the VLAN we just assigned by adding the device we just used to the VLAN Manager view. And we can see here that that device now has the VLAN of 70. As I mentioned a little earlier, we could have added our VLAN to the devices by selecting a topology map. Our topology application has an inbuilt connection with Google Maps. This is particularly handy if you have multiple sites, and it gives the administrator the ability to click on a site tag and be taken directly to that site in question. On the top right, we have a little icon which will take us directly to the logical network view. On the top left, we have a drop-down menu where we can select the map we wish to see. Here we have maps based on IP subnet, AP group, and the site name, and so on. As we can see here, the topology view gives us another quick way to scan the network for any issues. Devices that have a green circle are in a normal working state. An orange circle would mean that the device is in a warning state. You would see that there was a notification or alarm associated with that device, and a red circle to indicate that a device is down. Clicking on a device gives a context menu from where an administrator can perform a number of tasks. We have device-specific tasks, CLI scripting if we need to have access to the device's CLI. We can see notifications for that device, and we can perform a backup or image upgrade for the device. On to some wireless-specific capabilities and functions. Firstly, let's take a look at how to create an SSID. There are two ways to create an SSID. The first is to use the wizard-like interface to automatically create all of the different policies needed for SSID creation. Different policies would cover things like authentication strategy, network access control policy, etc. The second method, called Expert, gives the administrator the option to create all of the different policies one by one. Let's have a look at the wizard-based method. Click the plus icon to start the process. Give your SSID a name. And select a usage. The choices are for a secure 802.1x network, an enterprise BYOD, guest network, or protected network using pre-shared key. You can select if you wish that users go through a captive portal, and if that captive portal shall be the inbuilt captive portal provided by OmniVista, or a separate external captive portal, or BYOD registration. Once we have made our selection, click on Create and Customize. This page will change depending on the previously selected information to show the options required to complete the SSID creation. Here we choose the authentication server we want to use and the access policy, which maps the SSID to an authentication strategy. Here, the default is if the SSID equals the SSID name, then we will use our newly created access policy, which in turn points us to the correct authentication server. This gives flexibility if we have multiple authentication sources on our network and we need to point different SSIDs to different authentication servers. We choose the VLAN for our SSID. And below we have options to use web content filtering and walled garden with social login options for Facebook, Google, and Rainbow. Advanced access role configuration allows us to change some policies, including adding bandwidth limitation for the access role profile, client logging, and DHCP options. All of the information presented here can be modified by the administrator after SSID configuration if needed. We are not obliged to keep these settings or not have the flexibility to modify them. Advanced Wireless LAN Service configuration completes the options for SSID creation and configuration with things like roaming parameters, client data rates, and some more QoS settings for the SSID. Once you have completed the configuration here, the next step is to create the SSID and choose the AP group assignment. By default, the default AP group is selected, but we can change this here and either change or add another AP group. Clicking Apply commits the SSID to the AP group, and now those APs that are members of the selected groups will start to broadcast the newly created SSID. We have just assigned our SSID to an AP group rather than directly to an AP. AP groups are logical collections of access points where each member of an AP group will share common configuration settings. As an example, let's look at an AP group settings page. So here we configure global settings for an AP group where changes will be applied to all of the APs in the group. This means it is quicker and easier to modify multiple APs at the same time. Creating a group is simple. Click on the plus icon and then select the information you need for the AP group. Give it a name, an optional description, and then if you wish, change the settings. Otherwise, scroll down to the bottom and click Create. Once done, you then assign an AP to the AP group. Select an AP, edit the AP, and here we have the group name, and we can now select the new AP group. RF profiles can be customized to fit a client's needs. Stellar APs use an auto power mode by default, which modulates the power as needed to give the best coverage. However, the administrator can of course change this to suit their needs. As you can see, you have access to all of the options required to completely customize your wireless network. Let's have a look at the heat map functions. You can create different sites called a campus, different buildings per site, and different floors per building. We are looking at a heat map as generated by an algorithm within OmniVista. You upload an image of the floor plan, and you can add obstacles like walls, windows, and partitions, where each different obstacle has a different impact on the signal as it passes through. This can be used to ensure that you have the best possible placements for your APs, that there aren't any unexpected holes on the Wi-Fi coverage. It can also be useful when you want to add APs to the network to select the best placements, or if you intend to extend the network into a new area or building, and it can give you a good first indication of AP placement and coverage. We have seen how to add a switch and an AP, how to create an SSID and configure some core networking features like VLANs and IP interfaces. So what about securing the access to the network? In OmniVista, OmniSwitch and Stellar, we use something called an access role profile to provide network access control. This is sometimes referred to as a UNP, a Universal Network Profile, and this is part of our unified access approach. Unified access means that when an administrator creates access control profiles on the system, they are created once, stored centrally on OV, and are pushed to both wired switches and wireless APs at the same time, meaning that the same profile is used by users and devices regardless of how or where they connect to the network. If the user is using a wireless device and then decides to log into the network on a wired PC, that user will have the same network rights. That said, the system is flexible enough that an administrator can choose to give users different access rights depending on the device used, SSID used, or location within the network or time of day when the user is online. The policy is made up of a set of rules ranging from QoS and bandwidth control to IP allow and reject up to layer 7 using our application enforcement feature. So here we are creating a policy rule. So I'm going to add a name. The precedence is the order in which the rules will be executed. Here we declare which devices will be used with the access role profile. This is to allow OV to know how to present the following pages of the policy list. So if a policy is only to be used on a switch, then there will be different options for wired only rules. So here we're going to add an AP group, and here we can see the condition for the rule. This can be a MAC, IP, DSCP, a layer 4 service as well. Protocol or the port, and application visibility. So here we can use this. We can look for some app names. There are over 3,000 signatures. Let's look for YouTube. So we're going to select YouTube. So now we have our condition. Any traffic that matches YouTube is going to match this rule. And here we set our action. We can accept the connection and add restrictions, or we can just deny the traffic. So this means that anytime this rule matches, it'll drop any YouTube traffic. The validity period is when we're going to happen, so let's choose the working day. So basically, can't connect to YouTube during the working day, but you can outside of the working day. And we review what we have and we click collect. Adding multiple rules like that will build up the access control that we want for our policy. This is put into a policy list. We give our policy list a name and we select the policy from this drop-down list. Once we have selected all our rules, we can select the last rule. If you create an allow list, for example, then the last rule would be a deny rule, or vice versa. If the rules are all deny, then we'd be wanting to allow everything else. We have device default, which is depending if it's a switch or an AP, as one has deny all as its default, or one has accept all as its default. Now here we will declare our devices, so we're going to add our AP group, and we click on OK. So now we have our list. So we need to connect that list to a profile, an access role profile. Click Add, and we give our profile a name, and once that's done, we will select the list that we've just created from this drop-down menu. For the policy, we have some specific information like bandwidth control settings, client session logging. This is just for the policy. Once we are happy with our selections, we will push this to our devices. So here we have options for the mapping, VLAN, VXLAN, SPP, and others. So we're going to map it to a VLAN, and we've got to give it a VLAN ID. So I select my VLAN that I want to give to users who are given this profile. Need to select the device, so we will select our AP group here. We have period policy and location policy for the policy itself. Again, go through the review. Once we're happy, we click Apply. So now this policy can be used by a user or device on the devices we've just sent it to. In addition, although we will look a bit more closely later on, we can use them policies for an IoT device where the system automatically detects the device type, and we have the option to automatically assign a policy to that device. This forms the basis for network segmentation within your network by controlling users, devices, and traffic types that are permitted on your network. It can isolate segments of the network from each other, and you can give more or fewer rights to users or devices depending on your needs. Once you have set up and configured your network, then you will need to keep an eye on things on a day-to-day basis. To help with this, OV has some features to make life easier. Firstly is the dashboard screen. This is the default homepage for OV, where you can see multiple widgets giving you some information from different parts of the system. This view can be changed to suit your needs, allowing you to see at a glance what information is important to you. You can change the layout, or you can add and remove widgets. The first page is a global view, but up here on the left, we can change the view to be more wireless focused. You also have the option of changing the menu view to be more wireless focused. This does not change the menu options, but it does put wireless features in a more prominent view. Each widget has a link so that you can quickly go to that page in OV without needing to navigate to it. At all times at the bottom, you can see the notification alarms. Clicking on it will take you to the notifications page. Here you will find all of the alarms that have been generated by your devices, and this will allow you to see if there are urgent tasks to be performed. Backups of your devices and backup restoration are done via the Resource Manager. The home page shows a resume of past backups. To start a backup, click on Backup, and then you will be presented with a choice of how to select your devices, either individually, by topology, or AP groups. Click Add, and then select the device you wish to back up. You can, of course, select multiple devices. We can select the type of backup we want: a full backup, config only, or image only. What are we backing up? Just the certified directory or everything? Give the backup a description, and then either schedule your backup for later or execute it now. After a few seconds, you will see a list of notifications informing you of the backup's progress. Once completed, you will see a success message, and the device backed up will be listed in the main view. We saw earlier in the video that with application enforcement, it is possible to add Layer 7 rules to our network access control by applying specific individual or indeed groups of protocols and applications. This is done via the application visibility feature. You can add signatures to stellar access points and our OmniSwitch 6860E and 6860N switches to gather information on the traffic entering your network. There are over 3,000 signatures covering the standard network protocols, as well as many websites, gaming traffic, client-server protocols, and so on. Application monitoring and analytics displays the actual protocols seen on the network. For example, Here, we can see some standard protocols shown in a pie chart giving the percentage of each protocol seen. We also have an advanced view that displays all of the traffic that has been generated by clients on the network. We see the top 5 applications in the default view. This view can be modified to show a different number. And if we go to the other here, we will see the rest of the protocols discovered on the network. We see website traffic, client server traffic, along with standard protocols like NTP. So as previously discussed, we can add app-specific conditions to our NAC rules, and all of the protocols seen in the analytics report view could be chosen as a condition. OmniVista also has some tools for discovering or finding users and devices on the network. The home view for the authentication app shows a summary of client connections, including failures and the reason behind any authentication failure. The authentication record list is a real-time and historic view of devices and users logged into the network. You can refine this view by adding a search criteria to see all of the instances where this user was logged in. We also have a locator tool. You can search by user, IP address, or MAC address. This will show you results from net forwarding and ARP entries. You can show this as a live search as well. On the wireless LAN, you can see how many clients are connected to an AP and evaluate the user's connection experience by checking the traffic throughput. Here we can see the distribution of clients per AP and see which clients are on the wireless network. More detailed information on a client's wireless connection can be seen under the client list view. Another part of a network administrator's life is troubleshooting. Users can have connection issues, devices can lose network connectivity, there could be traffic spikes or poor traffic throughput, amongst others. For example, in the analytics application, there are reports for the network health. This is a collection of statistics for the switches on the network. Is the CPU usage within range? Is the temperature within an acceptable range? These can have an effect on switch performance. Top-end clients will give an indication if a client device on the network is generating a lot of traffic and having an adverse impact on the network. You can also add graphs for network port usage, PoE port usage, set thresholds, and generate alarms if breached. The application visibility function can give readings on traffic numbers showing any abnormal usage. Examples where this has been helpful in detecting problems is when there are misconfigurations on Windows machines, for example, that send out too many NetBIOS packets, which in turn have an adverse effect on devices on the network because this BUM traffic needs to be sent to every CPU. on the system, and this could interfere with devices if they become overloaded. With the analytics and the application monitoring application, we can detect NetBIOS packets, obviously, and add them to our views. Troubleshooting some user issues can include finding out why a user has not received the correct access role profile, if they have actually authenticated on the system, have they been placed into quarantine for some reason, is the device an IoT classified device which may change the device rights on the network. And so let's highlight some of the applications we have seen on OV and some we will go over in a few minutes, and consider automation tools. A main automation feature is network security rights being given to the user regardless of how they connect to the network via our unified access approach. This means that a user does not have to worry about receiving the correct network rights if they were to change devices or change from a wired to a wireless connection. A bit later on in this video, we will discover a mobile application that can be used to automatically add devices to an OmniVista Cirrus account by scanning the barcode or QR code located on Stellar APs and Omni switches. Instead of adding devices one by hand, this mobile application sends the information directly to the cloud. Also, by using the IoT application, administrators can automatically assign an access role profile, therefore giving previously unconnected devices the correct network access. Using a fingerprinting algorithm, devices that are discovered which fall into a predefined category can be onboarded without the need to do so by hand, freeing the administrator for other tasks. OmniVista also provides features to answer software-defined LAN and branch solutions. While we look at the procedure of the service creation, let's go over how some of this works. OV is the centralized SD-LAN orchestrator where services are created and policies are defined. Control plane is distributed in the network devices thanks to the IS-IS control plane. This means there's no dependency on OV's availability or reachability in case of failure. Traffic is not disrupted. The only limitation would be the ability to create or modify services if OV is not reachable. The LAN service is no longer tied to a device and port or VLAN, but rather to the user or device's role. The user or device is mapped to its role upon authentication, classification, or profiling in the case of IoT. OVN UPAM is the central point of policy definition, and the policy enforcement endpoint is the switch. These SD-LAN service definitions need only be enabled on edge devices. There is no need to configure them on core or distribution devices because the SPB control plane is responsible for configuring the required network paths. Furthermore, these services are not statically provisioned. They are dynamically initiated upon connection and are torn down and or recreated on a different device as needed as users connect, disconnect, and roam throughout the campus. Besides improving operational complexity with automated service reconfiguration, there are security benefits. First, the user profile can include dynamic ACL policies to implement software-defined micro-segmentation, a mobile security parameter, which adapts to the user or device role and movements. Second, services are only initiated after successful authentication. Services don't become active unless authorized users are connected, and this means the service is more secure because it cannot be hacked or disrupted with a denial of service attack if it's not active. What we have seen here so far is the creation of the dynamic SPB profile for the service, the access role profile for the user or device, mapped the access role profile to the SPB profile, and applied the authentication role to the desired ports. The next step is to create a user and map that user to its access role profile. Once the user has authenticated to the system, we can search for him using the locator tool. We can see here that the user has been given the access role profile or UNP of faculty which we created previously. We can also easily create point-to-point SPB services within OmniVista. What we're seeing here is the process of creating this static service. We will add the switches that will form the static link. And configure the SAP with the VLAN ID and description information. We're also going to add a common port. So this common port just means that the port reference will be used on both of the switches. Doing a refresh, showing the operational status up with a BVLAN of 4000. So going to the topology, we can select an option to see the SPB network and select the service that was created. Selecting both of the switches at the ends of the static link will show us the path taken through the network for this service. For SD branch, OmniVista Cirrus is a perfect solution. Due to its cloud-based nature, having different sites spread over a large geographical area poses no problem to centrally managing the sites, and deploying sites or extensions is made simple and easy. Let's take a look at adding devices via the mobile assistant, which automatically registers new devices to the cloud ready for use within OV. On screen, we saw an OmniSwitch and Stellar AP being scanned into OVC. So at the top, you will see the serial numbers that were scanned, and we see the devices waiting for first contact. Once the call home is initiated on the device, they will contact OVC and will go through an automatic onboarding process. After a few minutes, they will become manageable. With OmniVista, you can also manage third-party equipment. On this Cisco switch, via the topology view, we have access to certain features, for example, notifications. We can monitor the state of the switch, receive traps, and take actions as with ALE equipment. We manage third-party equipment via SNMP. You create the MIB set for your equipment and add equipment via the third-party device support menu. And you can import the MIB into OV to be able to manage the equipment. OmniVista provides an app called VMM for Virtual Machine Manager for managing network attributes for VMs. To manage the VM, add a username and password into OV. OV supports VMware, Hyper-V, and Citrix XenServer. The VM locator allows us to discover VM networks and VMs on our managed systems. You can perform a search to locate the VM that you're interested in. So as we can see here, using VMM, you can also get the information regarding your VM and the different values that are important for a network administrator. Also, through VMM, you can push your UNP or your access role profiles VLAN configurations. You have the option to add new or use existing values. You can also enable MVRP ports and enable one-touch SBP ports. Finally, let's have a look at how an administrator can check the integrity of a switch configuration using something called a golden configuration. As you can see, the third switch in this list has a sync status of no audit result. No audit has yet been performed on this switch, and no golden config has been declared. So, we define the configuration which will become the golden configuration for this switch. We choose a backup, which we trust, which includes the 3 files which were backed up. We can check the contents of the file to double check that the file contains the correct information. So this configuration is now the golden configuration for that switch. To show the audit in action, firstly, we need to go onto the switch and make a change. Just as a quick example, we change the system name to another value. We will commit and save the change to the switch. Going back to OmniVista, we can select our switch and audit it. We have a warning that a file has changes. We can select the file and inspect the 2 versions, and all the changes detected will be highlighted. At this point, we could enforce the golden config, so replacing the incorrect files, or create a new golden config from that source found on the switch. So what we'll do to continue the example is return to the switch and change the config back by hand. Now we have changed the value back to what it was and save the changes. Going back to OV, we can select the switch again and rerun the audit. And we can see straight away that the switch config matches the golden config, and refreshing the view shows that the switch is now in sync. And that concludes this video on OmniVista. Thank you very much for watching.